Hello students, welcome back to our channel. So students, in this video we are going to study another very important topic from class 12th mathematics chapter probability, and the topic is Bernoulli's trials and binomial distribution. To understand the meaning of Bernoulli's trials, first we have to understand a term in probability which is dichotomous events. What are dichotomous events? There are situations in probability in which there are only two outcomes possible. For example, if we are tossing a coin, then there are only two outcomes which are possible. Either you will get head or you will get tail. There cannot be a third outcome. So such type of events in which there are only two possible outcomes, they are called dichotomous events. There is another example. Suppose you have brought a bulb from a market, so there are only two possibilities. Either that bulb will work or it will be a defective bulb, it will not work, right? Or answer to a question, if there is a question, so there are only two possibilities. Either you know the answer or you do not know the answer, right? So such type of events are called dichotomous events. So Bernoulli's trials is basically related to dichotomous events. Bernoulli's trials is simply the trials of a random experiment. When we say trials of a random experiment, we mean that the number of times some experiment is being repeated. For example, let us consider the experiment of tossing a coin. If I am tossing a coin 10 times, then I will say that number of trials are 10, right? But to call the trials of a random experiment Bernoulli's trials, they should fulfill four conditions. Number one, when we are going to call the trials of an experiment as Bernoulli's trials, only then when they satisfy these four conditions. Number one, number of trials should be finite. Number of trials should be finite. Number two, there should not be infinite number of trials. If I am saying that a coin is tossed 10 times or 15 times or 20 times or 1000 times, that is okay, but number of trials should be known and should be finite. Number two, trials should be independent of each other. Which means that the probability of or happening or occurrence of one trial should not affect the happening or occurrence of the next trial, right? All the trials should be independent of each other. For example, when you toss a coin, if head comes in the first trial, so it is not going to decide what is going to come in second trial. Even if head comes in first trial, we do not know what is going to come in second trials, right? So trials are independent of each other. Number three, trial should be independent of each other. Okay, each trial should have only two outcomes, right? The dichotomous thing should have only two outcomes, and number four, the probability of success in each trial should be same. What is success? Success is success out of the two outcomes. Success can be considered as any one of the outcomes. For example, if I am tossing the coin and I am saying that what is the probability of getting ahead, then that getting ahead is the success. When head comes, I'll say that it is a success, and when tail comes, I'll say it is a failure. Or if I'm saying that what is the probability of getting a tail, then tail becomes the success and head becomes the failure, right? So the probability of success in each trial should be same. Even if I'm tossing a coin 10 times, 100 times, 1000 times, then for each trial the probability of getting a head is 1 by 2, right? So it is same in every trial. So these are the four conditions that should be fulfilled by the trials. Only then they will be called as Bernoulli's trials, right? Okay, so for Bernoulli's trials we have a formula of finding the probability of success, which is the probability of getting R successes in N trials, right? The probability of getting R successes in N trials means that we have performed an experiment N times and we want to see what is the probability of getting R number of successes. For example, I have tossed a coin 10 times and I want to see what is the probability of getting 6 heads, right? What is the probability of getting head 6 times? So n is 10 because that is the total number of times experiment has been performed, and R is 6 because that is the number of times I am getting the success, right? So the probability of getting R successes in N trials is NCR, and we will write it Px equal to R, where x is a random variable. X is a random variable which can have any value. So we are saying that x should have value R, right? So we should get R successes. NCR P raised to power R, Q raised to power N minus R. What are P and Q? P is the probability of success in one trial, probability of success in one trial, and Q is the probability of failure in one trial. For example, if I am tossing a coin, then P, if I am saying that getting a head is success, then P is 1 by 2 because the probability of getting head is 1 by 2, and when tail comes, that is a failure, and the probability of tail, which is again 1 by 2, is Q. So Q, because there are only two possible outcomes P and Q, so the sum of probability P and Q is 1. So we can say that probability of failure Q is 1 minus the probability of success. For example, okay, what is NCR? NCR is simply the combination coefficient which you have studied in binomial theorem in class 11th, or permutations and combinations. What is the expansion of NCR? Expansion of NCR is n factorial divided by r factorial into n minus r factorial. And what is n factorial? N factorial is n into n minus 1 into n minus 2 into n minus 3 till 1. For example, 5 factorial is 5 into 4 into 3 into 2 into 1. Now let us see this question. If a fair coin is tossed 10 times, find the probability of exactly 6 heads. Find the probability of exactly 6 heads. So in this case n is 10 and in first case r is 6, right? P is 1 by 2 because probability of getting a head is 1 by 2 and probability of getting a tail, which is failure, that is also 1 by 2. So we have to find Px equal to 6, which is 10C6 P that is half raised to power 6 into Q that is also half raised to power n minus r, which is 4. So the answer is 10C6. This is 1 by 2 raised to power 6 and this is 1 by 2 raised to power 4. So when we will add, this becomes 1 by 2 raised to power 6 plus 4, that is 10. Now we will expand this 10 factorial divided by 6 factorial into 10 minus 6, that is 4 factorial into 1 by 2 raised to power 10, or you can calculate it further, right? Okay, in second case we are supposed to find the probability of at least 6 heads. At least 6 heads means number of heads should be 6, number of heads can be 6, number of heads can be 7, can be 8, can be 9, can be 10. So what we will do, we have to find the probability of this x equal to 6, then 7, then 8, then 9 and 10, and we have to add them all together. This is the formula using which you are going to find the probability of Px equal to 7. You will put 7 here and 7 here and 10 minus 7 here, then for 8, then for 9, then for 10, and you will add all of them. And at most 6 means in third case you have to find the probability of at most 6 heads. That means maximum number of heads should be 6. So this contains the probability of getting 0 heads or 1 head or 2 head or 3 head or 4 head or 5 head or 6 heads. So you have to add all these. Px equal to 0 plus Px equal to 1 plus Px equal to 2 plus Px equal to 3 plus Px equal to 4 plus Px equal to 5 plus Px equal to 6, right? So using this formula you can put the values and find the total value. Okay, what is binomial distribution? Sometimes a question comes in which it is not given that we have to find the probability of a particular event. It is just given that we have to find the probability distribution of a random variable. For example, let us consider this question. A coin is tossed 4 times, right, or 3 times. A coin is tossed 3 times. Find the probability, the binomial distribution or we should take more than 3 times because 3 wala is very easy. Okay, a coin is tossed suppose 5 times. Find the binomial distribution of number of heads, right? Find the binomial distribution of number of heads. So now in this question it is not given that we have to find the probability of a particular event, that find the probability of getting 4 heads or 3 heads. No, it is given that find the probability distribution of number of heads. That means we have to consider every possible situation. Now if we are tossing a coin 5 times, then what are the possible, suppose let us take a random variable x, which is the number of heads, right? Number of heads in tossing a coin. Now if we are tossing this coin 5 times, then what are the values, what are the possible values of x? 0, because if we are tossing a coin 5 times, then all 5 times we can have tail, so there will be no head, so 0. Or we can have add head 1 time or 2 times or 3 times or 4 times or 5 times. So these are the all possible values of x. So we have to find the probability for all these values. So for 0, the probability of success is 1 by 2 and the probability of failure is 1 by 2 and number of trials are 5. So we will write 5C0 half raised to power 0 and again half raised to power 5 minus 0. 5C0 is 1 and this is 1 by 2 raised to power 5 and 1 by 2 raised to power 5 is 1 by 32. So probability of getting no heads when 5 heads are tossed, that is 5 coins are tossed, 5 heads are tossed, 5 coins are tossed, that is 1 by 32. Okay, P x equal to 1. Okay, 5C1 1 by 2 raised to power 1 and 1 by 2 raised to power 5 minus 1. The total power of 1 by 2 is always going to be 5, right? 4 plus 1 again 5 and 5C1 is 5, so it becomes 5 by 32. P x equal to 2. 5C2 1 by 2 raised to power 2 1 by 2 raised to power 5 minus 2. 5C2 is 10, so it is 10 by 32, which is 5 by 16. P x equal to 3. 5C3 1 by 2 raised to power 3 1 by 2 raised to power 5 minus 3. 5C, this is again 10 and this is going to be again 5 by 16. Okay, now P x equal to 4. 5C4 1 by 2 raised to power 4 1 by 2 raised to power 5 minus 4. 5C4 is 5. Now this is again 5 by 32 and the last one is Px equal to 5, which is 5C5 1 by 2 raised to power 5 and 1 by 2 raised to power 5 minus 5. 5C5 is 1 and this is 1 upon 32. Okay, so we have the probability of all possible values of x. Now we have to make a table like this, and that table is called the binomial distribution table. Create a table. Okay, now divide it into 2 rows. In first column you are going to write x and in second you are going to write, in first row of first column you are going to write is x and in second row of first column px. So what are the values of x? X has values 0, 1, 2, 3, 4 and 5. Now make all possible columns of the values of x and put the value of the probabilities. So when the x and when the value of x is 0, then probability is 1 by 32. So 1 by 32 should come in this box, and then 5 by 32 should come in this box, and then again it is 5 by 16, then it is 5 by 16, then 5 by 32, and then 1 by 32. Right? So this is binomial distribution of number of heads in an experiment in which a coin is tossed 5 times. Right? So these were Bernoulli's trials and binomial distribution. I'll meet you in next lecture. Till then, all the very best.